Now the next Cartesian product, which is one of the most important operation in relational algebra. Why? Because in the SQL, while we are going to study the SQL, if there are multiple relations, okay, in the query. Now, if there is a single relation, it is very simple to write the SQL query. But when there are multiple relations, means instructor course both we need to use, instructor department both we need to use, student instructor both we need to use. If there are multiple relations, more than two relations, then it is related to the Cartesian product of relational algebra. So if once you understood this Cartesian product in relational algebra, then it is very easy to write the SQL queries if there are multiple relations. So first try to understand what is relational algebra Cartesian product operation. So the Cartesian product operation, it is denoted by the cross. As we use multiplication symbol in normal mathematical writing, we use cross as a multiplication symbol. So the Cartesian product operation denoted by a cross allows us to combine the information from any two relations. So mathematically, how we write R cross S, R Cartesian product S, it is the tuple T and Q together combined, where T belongs to R and Q belongs to S. Means what it performs? It attach every tuple of R with every other tuple of S. It attach every tuple of R with every tuple of S. That is TQ combined together, all the tuples of R and S. See with example, then it becomes simple. Consider two relation. I write here two relation. Instructor Cartesian product teaches. Okay. Instructor Cartesian product teaches. So it combines all the tuples of instructor with all the tuples of teachers. Means in the resulting relation, how many number of attributes? In the resulting relation, the number of attributes are union of R and S. Means if there are 4 attributes in the instructor and 4 attributes in the teachers, then there are 8 attributes in the resulting relation. So here in the instructor there are 4 attributes: ID, name, department name and salary. And in teachers, ID means the courses that is taught by that instructor, that is teachers relation. So it includes instructor ID, then course ID, section ID, semester and year. Means in instructor relation there are 4 attributes and in teachers relation there are 5 attributes. So in the resulting relation there are 9 attributes. So how we represent instructor Cartesian product teaches? In the resulting relation the attributes are instructor dot ID, instructor dot name, instructor dot department name, instructor dot salary. Now after that the attributes of teachers, that is teachers dot ID, teachers dot course ID, teachers dot section ID, and teachers dot semester, and the last teachers dot year. Okay, so total 1 2 3 4 5 6 7 8 9 attributes there are in the resulting relation. Means if there are R attributes in the resulting relation, S attributes in the second relation, then in the resulting relation, R union S number of attributes. Okay. Now, for the attributes which are unique, means not combined in both the relation, that attribute not necessary to use the prefix. The attributes which are appear in only one relation, for that attribute not necessary to use the prefix. Means name appears only in the instructor, department name appear only in the instructor. Okay. Then salary appears only in the instructor. Teachers dot course ID appears only in the teachers. Section ID appears only in the teachers. Semester appears only in the teachers and year appears only in the teachers. But ID appears in both the relation, and that's why we need to use the prefix to indicate that this ID is from the instructor relation and this ID is from the teachers relation. For remaining attribute which appears only in one relation, not necessary to use the prefix, and that's why here the resulting relation, the attributes are like this. In the instructor relation, resulting relation, the attributes are instructor dot id, name, department name, salary, teachers dot id, then course id, section id, semester and year. Okay. So in this way, the first part of this Cartesian product, that in the resulting relation the number of attributes is union of both. So this is instructor relation with these 4 attributes. This is the teachers relation with this 5 attributes. Then in the resulting relation you can observe there are 9 attributes. Only for ID the prefix is used, instructor.id and teachers.id. Instructor.id and teachers.id. Now, if in the first relation there are n1 number of tuples in the instructor relation and in the teachers relation there are n2 number of tuples, then in the resulting relation how many number of tuples are there? These are n1 into n1, n2. Why? Because this one attach every tuple of the instructor with every other tuple of the teachers. You can observe that this tuple of instructor, it is attached with every other tuple of teachers. This second one attached with every other tuple. This one attached with every other tuple. And that's why in the resulting relation, the number of tuples are n1 into n2. You can observe here. Means if in the instructor relation there are 12 tuples and in the teachers relation there are 15 tuples, then in the resulting relation of Cartesian product there are 108 tuples. Why? Because every tuple of instructor attached with every other tuple of the teachers. You can observe the first tuple of the instructor attached with all the tuples of the instructor. Second tuple attached with all. Third tuple attached with all, in this way. Not all are shown in this. It is not possible to show all 180 tuples in the single page, and that's why some of them are shown here. So total there are 180 tuples in the resulting relation n1 into n2. Okay. Now see how we can use this Cartesian product for a particular state problem, solve a particular problem statement. Suppose the problem statement is that, or the query statement is that, find the name of all instructors in the physics department together with the course ID of all the courses they taught. So read again. Find the name of all instructors in the physics department together with the course ID of all courses that instructor taught or they taught. So here when we see this query, first we need to identify which relations are required here. First we need to identify which relation or single relation is sufficient. If not, then multiple relation, then which relation. So here it is given that the department, physics department means the predicate is that department name should be physics, correct? Means in which instructor and its physics department. Means we require instructor relation. Means we require instructor relation. Why? Because it's a physics department. So in the instructor relation, the ID is there, name of the instructor is there. We want name of the instructor. So name of the instructor is there, then department name is there and salary is there. Means definitely we require the instructor relation. Now the remaining query together with what we want, course ID of all courses they taught. Now course ID is available in the instructor. No, course ID is not available in the instructor. Means we want those instructor who teaches this course ID, and those instructors are from the physics department. So it is confirmed that we require the instructor relation. Along with that, which relation we require? Where the instructor ID and course ID is available. Why? Courses which is taught by that particular instructor that we want. Means we need such a relation where instructor ID is there and also course ID is there. Correct. So it is a teacher's relation where the course ID and instructor ID both are available. So I have written here only subquery. Select those tuples from instructor into teachers. Cartesian product we need to use as there are two relations. Instructor into teachers where department name is equal to physics. So from this, after executing this query, or how this query execute, it first make the Cartesian product of these two relations, and from that find out only those tuples, select only those tuples where department name is equal to physics. How the query execute? It first make the Cartesian product of two relation, instructor into teachers, and from that select only those departments where department name is equal to, or select only those tuples where department name is equal to physics. Okay. So in our example, the result is like this. 180 tuples are there in the instructor into teachers. Total 180 tuples. Among that 180 tuples, only these tuples are selected where department name is equal to physics. Now, looking towards this result, can we think is it correct result? Is all these courses, whatever the course ID given, all are taught by Einstein? All these courses were given, all are taught by Gold? No, it is wrong. See, it is a CS, means it is a computer science course. Then it is not taught by the Einstein. CS, it is not taught by Einstein. If finance, music, history, not taught by Einstein in our original relation. But here in the result, it happens. Then why it happens? The question is important that here we get some values which are not correct, or incorrect values or incorrect result we get here. Here we get all such courses that are not taught by that particular instructor. Why it happens? It happens because the Cartesian product operation combine every or attach every tuple of instructor with every other tuple of teachers, and here we can observe that the instructor ID is not equal to teachers ID in most of the tuples. instructor ID is not equal to teacher's ID in most of the tuples. Both are not equal. Here only it is equal. Means what? We need to select only those tuples where instructor.id is equal to teachers.id. We need to select only those tuples where instructor.id is equal to teachers.id. Means here we need to add another predicate that from this result select only those tuples where instructor.id is equal to teachers.id. Means we need to apply another selection here to get the correct result. Why? Because in most of the tuples instructor.id is not equal to teachers.id, and that's why we get a wrong result. And to avoid this, we need to apply some another selection. Such kind of it forces equality on those attributes which are common in both the relation. So which attribute is common in both the relation? Instructor ID and teachers.id. So we need to apply selection on this attribute which is common in both the relation. And that is the drawback of Cartesian product. That is the drawback of Cartesian product, that we need to apply another selection forcing equality on those attributes which are common in both the relation. Result means we need to apply another, here you can see we need to apply another selection. Instructor.id is equal to teachers.id, and once we apply this, only one tuple we get in the result. You can observe here where instructor.id is equal to teachers.id. And now in the final result, what we want? Name of the instructor and the course ID together, course ID. So here again on this we need to apply project name comma course ID. Project name comma course ID. From this what we need? Only name and the course ID. So in the resulting relation there will be only name of the instructor and course ID. So in this way, whenever we solve such kind of queries, we need to first write the sub query. Means what we have done here? First we make the Cartesian, how this query execute. In the same way we have to write it. First it make the Cartesian product of instructor into teachers. Then it find out only those tuples where department name is equal to physics. Then apply the selection forcing equality on those attributes which are common in both the relation. If there are multiple attributes in common, we need to apply it on multiple attributes. Then from that find out or project only those attributes we wish to appear in the result. Means in this way the query actually execute. We write it in this sequence or we see it in this sequence, but actually it execute in this sequence, and we need to write also in this sequence, then it becomes easy to write a query. If you start to write it from here, then it is difficult. Okay, so whenever such kind of query is there, first identify the relation which we need to or on which the query is going to execute. If more than multiple relation, we need to use the Cartesian product. If there is a single relation, no issue. Then selection and then projection. Most of the time projection is used at the end, and these brackets are important. These brackets are important, whatever we used here. So Einstein with physics, that is the final result. Now rename operation, it is a simple operation. So rename operation, it is used to rename. Now see, this is the result of this query, entire query. This is the result of this entire query. What is the name of this relation? No, there is no name to the resulting relation. It is only a relation with attribute name and course ID. There is a single tuple in the result. The name is not there for this relation. So rename operation is used to rename it. Rename operation is used to rename it. So allow us to name and therefore to refer to the result of a relational algebra expression. We can rename that result. Allow us to refer to a relation by more than one name. So the notation used here is that this one Greek letter rho. What we call it as a Greek letter rho. Like a P. It is like a P. It is a Greek letter rho which is used to rename the resulting relation or any simple relation also you can rename. So returns the expression E, whatever the expression E under the name X. So here I am going to write a simple example. I am going to show you the simple example. For example, suppose we want to find the only or the instructors find the 1 minute. Okay, find the physics department instructors only. Okay, we want only the physics department instructor. So how we write the query? In that case, simple query. What is the expression there? First we need to write it. We want the physics department instructors. So the query is like this. Correct, select department name is equal to physics from instructor. So this is a simple query, simple expression, this E. Now I want to give some name to this. I want to give some name to this. So I use the row and the name that I want to give. Or I want to rename the result, that physics instructors. Physics instructor. So whatever the resulting relation, name, sorry, ID first, ID, name, department name and salary. So whatever the resulting relation, the department name is equal to physics only. Why? We write the query, select the department name equal to physics. What is the name of this relation now? The name of the relation is physics instructor. What is the name of this relation? Physics instructor. That is the use of rename operation to rename the resulting relation, or also you can rename the existing relation, any existing relation. Now, if a relational algebra expression E has n attributes, okay, and among that n attributes, we want to rename it with the new name. We want to rename it into a new name. So in that case, you can rename the attributes also with new name A1, A2 to AN. So I write the same query again. Row physics instructors, the name I am going to give you, and the attributes, 4 attributes in the resulting relation. To that attributes, I want to give name, IID, name, and without department name physics is there. Suppose I want to give it a name physics department and salary. And my expression E is select department name is equal to physics from instructor. So the result of this relation is 4 attributes: ID, name, department name and salary. But here I rename the department name with physics department. So in the resulting relation, the attributes are ID, name. Instead of department name, it becomes physics department and salary. Means we change the attribute name. See, the resulting relation is not stored in the database. The resulting relation never stored in the database. It only calculated. The values are only, query is only executed, and these are available as a result but not stored in the database. That is about the rename operation. The example is given here. Now see, the rename operation, another use is that suppose you want to compare the same relation with each other. Means instructor into instructor. I want to make the there is such a query. It's a homework for you. Try to find out such a query where instructor, suppose I want to compare instructor's salary with itself. Then I need to make the Cartesian product of instructor into instructor. Then how to recognize the attributes from this one or this one? So in that case, the second one we can rename as IN instructor. Second one we can rename with IN instructor and then make its Cartesian product. So the second one is IN. So in this way, when we need to compare or when we need to make the Cartesian product of same relation for any query, then in that case, the rename operation is mostly used. Now, the formal definition, whatever the basic operations we have already seen, using that basic operation, the formal definition of relational algebra is a basic expression in the relational algebra consists of either a relation in the database, means instructor, whatever in this way, a constant relation and some expressions. Suppose E1 and E2 be the relational algebra expression, any kind of expression, select, project, rename, Cartesian product, set difference, union, include anything. The following are relational algebra expression: E1 union E2, E1 set difference E2, E1 Cartesian product E2. We can use select operation to find only those tuples, select only those tuples with predicate P is true. Then project operation, it lists only those attributes which we wish to appear in the result, and also we can use the rename operation to give a new name to the result of E1. So that is the formal definition of relational algebra. Now we start with the additional operation. So we define additional operation that do not add any power to the relational algebra. Do not add any power but simplify common queries. With basic operation we can write any query. With basic operation of relational algebra we can write any query. But to simplify some of the queries, common queries, additional operations are used. So there are four additional operations: set, intersection, natural join, assignment and outer join. So first we start with set intersection. So set intersection, as in mathematical notation we also know that it is denoted with this one, intersection. The same symbol, mathematical symbol is used here. So R intersection S, it is the result in the set of tuples T where T belongs to R and T belongs to S. Means T should be appear in both the relation. T should be appear in both the relation. So T belongs to R and T belongs to S. So again, as it is a binary operation, R intersection S. So in this again it must satisfy two constraints. The first one is that R and S must have the same RIT, means same number of attributes, and the attributes of R and S are compatible. Domain of the attributes R and S must be compatible. So what it simplifies? It simplifies the set difference. Instead of R intersection S, we can use the set difference in this way. Means the result of these both are same. It is used to simplify this set difference operation. Now see it with example. To find all courses taught in fall 2009 semester and in spring 2010 semester. We want all the courses that taught in fall 2009 and spring 2010. Previously same query we have seen, but in that or is there, so we use union. In the second one, find all courses that taught in fall 2009 but not in spring, so we use set difference. But here it is asked that taught in both the semester. Okay, so I write again the sub query. Here you need to write the sub query first. What is the selection? Semester. Select those tuples where semester is equal to fall and year is equal to 2009 from section relation, and from that find all courses, means course ID only. So project course ID. Similarly, another subquery I write here, semester is equal to spring and year is equal to 2010 from section, from that only find out the course ID or project course ID. Okay, so two results we get and then we combine it such that taught in both the semester, and in this case we use intersection. That is a simple example of intersection. Now the next one, natural join. So natural join, it is an extension to the Cartesian product. What is the disadvantage of Cartesian product? Is that we need to apply selection on those attributes which are common in both the relation. The natural join is a binary operation that allows us to combine certain selection and Cartesian product into one operation. Certain selection and Cartesian product into one operation. It is denoted by the symbol, this one, join symbol. How we define the natural join? The natural join operation forms a Cartesian product of two argument relations. Natural join operation forms a Cartesian product of its two argument relation, performs a selection forcing equality on those attributes that appear in both the relation or common in both the relation, and finally remove the duplicate attributes. That is important in natural join. Means in Cartesian product, if there are instructor ID and teacher's ID, both are there. Okay, instructor.id and teachers.id. Both are same attributes, but that appear in the result. But in natural join, it appears only once. Why? It removes the duplicate attributes. Again, I am repeating the definition. You need to remember the natural join operation forms a Cartesian product of two argument relation, performs a selection forcing equality on those attributes that appear in both the relation, and finally remove the duplicate attributes. Now see it with example. This is the result. Previously, for this previous we have seen the Cartesian product. Here you can observe ID, name, department name, salary, course ID, section ID, semester. 8 attributes are there. Why? Because ID appears only one. And also it forces equality on those attributes which are common, selection. So it appears only those tuples where instructor.id is equal to teachers.id. So the same query, how we can write it in Cartesian product? Select instructor.id is equal to teachers.id instructor Cartesian product teaches. Why? Because instructor Cartesian product teaches it generates a relation of 180 tables. In most of the tables, instructor.id is equal to not equal to teachers.id. So we need to apply this selection here. But here it combines this Cartesian product, the selection forcing equality on those attributes which are common, and also remove the duplicate attributes. So id appears only once in the natural join operation. That is simple natural join operation. Now same, find the name of all instructors in the physics department together with the course ID. Now the same query, find the name of all instructors in the physics department together with the course ID they taught. This query, how we write here this way. Name, course ID, instructor, teacher. Means here not require the selection forcing equality on those attributes which are common. Why? Because the natural join operation itself apply the selection. And from that physics department only Einstein with physics. If we write the same query in the Cartesian product, then how we write it? In this way. Okay, so here this instructor.id is equal to teachers.id we need to write. Why? Because it is a drawback of Cartesian product. But in natural join it is not required to apply this selection. Okay, here we directly use or don't use this selection on those attributes which are common. So relations R and S, the formal definition of natural join. If it is a natural join of two relations R and S denoted by R natural join S is a relation R natural join. The attributes are R union S. All the attributes from both the relation and union automatically remove the duplicate. So duplicate attributes are removed. Forcing equality on those attributes which are common, we consider that A1, A2, AN, these are the attributes in common and then make its Cartesian product. That is natural join. If there is no attribute in common, okay, if R and S are the relations without any attributes in common, for example, instructor and take any other or not instructor, course, department, everywhere department name is there. We can take any student and section. So in this no attribute is common. So if we perform the Cartesian natural join of these two, it is like a Cartesian product. Why? Because there is no attribute in common. If there is no attribute in common, then natural join and Cartesian product both are same. Another example is given here. Find the name of all instructors in the computer science department together with the course title of all courses that the instructor teach. Read, find the name of all instructors in the computer science department with the course titles of all courses that instructor teach. So first we need to identify the relations on which this query execute or evaluate. To evaluate this query, which relations are required. So here we require three relations to solve this query. In the course, title is there which wish to appear in the result. In the instructor, name is there which we wish to appear in the result. Then a department name is there in the instructor on which we are going to apply the predicate. But to understand which courses teach by which instructor, we need the teachers relation. Means it is the for to evaluate this query, we require three relation. So instructor, natural join teachers, natural join course, After performing the natural join on all these three, from that we get only those tuples where department name is equal to computer science, and from that project only name and the title. Project only name of that instructor and title. So this is the result. Bradant game design, teach the course game design. Bradant image processing, cards, image processing, cards, introduction to computer science, Srinivasan. So these are the 5 teachers which are from the computer department, science department, and these are the titles of the courses teach by that instructor. Means here we need to perform the natural join of 3 relations. So when we apply the natural join or Cartesian product, it is associative. Means instructor teaches and how this will execute. Actually, the question is that how these 3 executes or how the natural join operation perform. So simply it first make the natural join of these 2, and whatever the result, make the natural join with this course. Or it is associative, that's it is given here. Either these 2 are performed first and the result, whatever the result of this, it is natural join with course. Otherwise, these 2 are performed first, or this natural join of teachers and course is performed first, and it is then the result is natural join with instructor. It is associative, then also cumulative. Means we can change the position also, not necessary to write in the same sequence. You can write it in any sequence by it is commutative. So the natural join operation is associative and also commutative. Now next, simple assignment operator. The assignment operator is a simple operator as we use any programming language. It is denoted with the arrow, left arrow, and only used to assign the values on the right hand side to the left hand side. Whatever the values on the right hand side, these are assigned to the left hand side. It is normally used to give temporary name or temporary variable to the resulting relation, subquery. For example, we write previously the query for intersection, selection, etc. We write first query and give it name as result 1, assignment operation, the project, course ID, the courses that taught in both the semester. Select from section, we select those fall in semester, fall and year 2009 from section. Okay, and I use R2 temporarily assignment. It is for course ID semester is equal to spring and year is equal to 2010 from section. Okay, and I want the final result, the courses that taught in both the semester. So result is equal to R1 intersection R2. If I want another result were taught in R1 or R2, or taught in first but not in second, set different. So that is assignment operator, which is used for assigning the LHS value to the RHS value to the LHS variable normally, as we use in programming languages. Now the next one, outer join. So the outer join operation, it is extension to the natural join operation. It is deal with the missing information. It is deal with the missing information. So it is operation that avoids loss of information. It is the operation that avoids loss of information. It computes the join and then add the tuples from one relation that does not match the tuples in other relation. We'll see it with example, then it becomes clear. Okay. So, missing, loss of data means what? Missing content means what? Now see, it has here two examples are given. Two relations are given, instructor 1 and teachers 1. Instructor 1 has these three attributes and teachers has these two attributes. Three tuples are there in both the relation. It is example. Okay. Instructor 1 and teachers 1. Now we want to make the natural join of these two. We want to make the natural join of these two. So instructor teaches natural join. What is the result? What natural join operation perform? It perform the perform the Cartesian product, means attach every tuple of instructor with every other tuple of teachers, forcing equality on those attributes which are common in both the relations. So in the resulting relation, this one equal, so it will be in the result. This one equal, that's why it will be in the result. But here it is not equal to this one, so it will not appear in the result. This one not matches with any of the tuple of instructor, so this is not in the result. It forces equality on those attributes which are common and remove the duplicate attributes. ID appears only once. So this is the result of natural join. So which information we are missing here? We miss the information about the instructor Mozart from the music department. Why? Because Mozart not teaches any course. Or we miss the information about the course Bio 101. It's the name and department name. Okay, the name and department of that instructor who teaches the course Bio 101. It is not here. That we call loss of information or missing information. That we call loss of information or missing information. Again, I am repeating. Suppose there are these instructor 1 and teachers 1. These two relations are there, and we make the natural join. So it first make the Cartesian product, attach every tuple of instructor with every other tuple of teachers, and then after that it forcing selection on those attributes which are common. So 2 will appear, we miss the information about these two, and this is known as loss of information, or we can call it is the drawback of natural join. So how to avoid this loss of information? For that we use the outer join concept. To avoid this loss of information, and for that purpose we use outer join operation. So outer join operation is divided into three types: left outer join, right outer join, and full outer join. So first we are going to see the left outer join operation. So the left outer join operation is the one in which it takes all the tuples. I am going to read it first, then we'll show you with example. It takes all the tuples from the left relation that it takes all the tuples from the left relation that did not match with any tuple in the right relation. Pad this tuple with the null values for all other attributes from the right relation and add them to the result of natural join. See, what is the meaning of this? It takes the tuples from the left relation that did not match with any tuple in the right relation. So which tuple is not matched with right relation? This tuple is not matched with the right relation. So what it performs? It takes this tuple from the left relation, add the null values for those attributes which are in the right relation, and add this tuple in the resulting relation. Means it add a tuple 1 5 1 5 1. It takes all the tuples from the left relation that does not match with any tuple in the right relation and attach a null value for those attributes which are from the right relation. So which attribute is from right relation? Course ID. So attach here null value. So in this way, we'll get the information about 15151 also. Similarly, the next one, that is right outer join. It takes the tuples in the right relation that did not match with any tuple in the left relation. Pad these tuples with null values for all other attributes from the left relation and add them to the result. So, in our example, it takes all the tuples from the right relation that did not match with any tuple in the left relation. So, this relation not matches with this one. So, it takes this tuple 76766 from right relation. So course ID is there, bio, and attach null value or add the null value for those attributes which are from the left relation. So which are from the left relation? Name and department. Name. So add for it null null and attach it to the resulting relation. In this way, we'll get the information about these tuples. This is the result. Here we will get the information about 76766, but the null value for name and department name. And the next one, that is full outer join. So full outer join operation does both left and right outer join. So padding the tuples from the left relation that did not match with any tuple in the right relation. So this one that did not match with any tuple in the right relation. Attach a null value for those attributes from the right relation as well as the tuples from the right relation that did not match with any tuple from the left relation, and attach the null value for the attributes from the left relation. And in this way, we use full outer join. The notation for outer joins are like this. The left outer join, it is like a natural join. Only for left outer join we add in this side. For right outer join, it is like this. And for full outer join, it is like this. That is the only difference between the signs. So in this way, the outer join operation is used for find out the tuples which are of loss of information. Whatever we lose the information in the case of natural join, for that purpose this one is used, that is outer join.